Okay guys, today this is the way I have to do the review. I did go ahead and recorded once today and the video got corrupted. So this is what we're doing. So you're just gonna have to go along with me. So problems 1 through 3. This is just like your test. You guys just need to make sure you understand how to do these ones. First thing it says is determine the quadrant that each angle lies. So I'm gonna do this one first, number 2. Number 2 says negative 11 pi over 9. Negative 11 pi over 9, the very first thing you need to think about is the denominator. So I'm going to draw my axis, and I'm starting right here. And because it has a denominator of 9, and it's negative, I'm going to be going clockwise, which means I have 9 pi over pi here, negative, and on the right-hand side, negative 18 pi over 9, because that is 2 pi. I need all 9 slices at the bottom. And then I need 2 more slices at the top. So therefore, here's where negative 11 pi over 9 is going to be at. So therefore, I'm in quadrant 2. Okay? Next, number 3. Number 3 is going to be negative 2. Again, I told you guys to memorize your quadrants, not just in radians and degrees, but also in decimals. And this is negative, so again, we're opening clockwise. So I start here at 0. This is going to be negative 1.57, negative 3.14, which is pi, negative 4.71, and then 2 pi is negative 6.28. So we need to be opening right here. I'm going to start here, and then I'm going to go all the way down to negative 2, which means I am now going to be in quadrant 3. Okay? I am really not worried about problems 4 and 5. You guys can do that yourselves. Problem number 6 through 9. It says express each degree measure as a radian using pi. So this is whenever you're either multiplying by pi over 180 or by 180 over pi, depending upon where you're wanting to go in these two sections. So the direction says that you are going to go from a degree to a radian. So that means you need to cancel out your degrees, so therefore your degrees are going to be on the bottom. The 0 and the degree sign cancel out, and I'm left with 15 pi over 18. They both are divisible by the value 3, sorry. So 15 divided by 3 is going to be 5 pi. 18 divided by 3 is going to be 6, and you're going to have 5 pi over 6 radians. And that is your answer, and that's how you'll do 6 through 9. Next section is going to be problems 10 through 13. And it says express each radian measure as a degree measure. What that means is you are going to, I'm going to do problem number 10. So this time I need my radians to cancel out. So I'm going to have 180 degrees on top and then pi on the bottom. Those cancel out. So I'm left with negative 7/4 times 180 over 1. 180 divided by 4 is 45. And then you're going to have 45 times negative 7 is negative 315 degrees. And that is done. And again, you guys can all use calculators for that. That's not a big deal at all. Just wanted to make sure that you knew how to do it by hand as well. The next page, I should say, the next section is 14 through 16. Complement and supplement. And this is a review term from geometry. Complement is going to be 2 angles that add to 90. Supplement is going to be 2 angles that add to 180. The biggest thing you need to do when you're doing these problems is make sure the complement even exists. The only way the complement exists is if you are located in quadrant 1. So immediately, I'm going to say my denominator is 7. So here's 7 pi over 7, and here's 14 pi over 7. I have 7 slices in the top, 7 slices in the bottom, and I only want 2 out of the 7, which means this is in quadrant 1. So since I am in quad 1, the complement exists, so therefore I'm going to take 90, which is equivalent to pi over 2, and I'm going to subtract 2 pi over 7. When you are adding or subtracting fractions, you must have a common denominator. The common denominator is 14 here. So what did I multiply 2 by to get 14? 7, so that's 7 pi. What did I multiply 7 by to get 14? I did 2, so that's going to be 2 times 2, which is 4 pi. 7 pi take away 4 pi is going to be a 3 pi over 14 as my complement. Supplement is done similarly, except for those have to be 180 degrees. So I'm going to have pi minus my original angle of 2 pi over 7, understanding that 1 pi is the same thing as 7 pi over 7. So 7 pi take away 2 pi is going to be a 5 pi over 7, and that is going to be your supplement. Please understand that without a shadow of a doubt, I will have on the test one where that there does not have a complement because it is larger than 90 degrees. So pay attention. Number 16 is clearly one of those examples where it is larger than 90 degrees, so therefore it will not have a complement. Next page. The next page, it says find the length of the arc on the circle with the given radius that is intercepted by a central angle of the given measure. You are using S is equal to R times theta. R is known as your radius, and theta is the central angle, and it must be in radian measures. If it is not in radian measures, you cannot get a measurable distance, and it cannot be put on the number line. So on number 17, I give you 3.8. The 3.8 represents the radius, and 330 degrees represents your angle. However, that angle is useless to us because it is not in radian mode. So we have to take 330 degrees and immediately multiply it by pi over 180. Okay? Now, with that being said, you are immediately going to see that that's going to be 11 pi over 6, and that is what's going to be equivalent to the 330 degrees. So from there, I just am going to use S is equal to R times theta, and I'm going to plug in what I know, 3.8 times 11 pi over 6. You're going to take your trusty calculator here, which I doubt you all can see very well, but we'll try it out. We have 3.8 times 11 divided by 6, and then times that by pi, okay? And hit enter, and you are going to have 21.9. So my arc length is going to be 21.9 centimeters. And that is your arc length, and that is how you're going to do those problems on the test. Now, I will always make you find arc length. You may have to find the central angle, or you may have to find the radius. Just know that that formula, S is equal to R times theta, is what is going to be used every single time. The next section is going to be the directions. Determine a positive and negative coterminal angle to the following angles. So number 19 is the one I'm going to focus on. Notice that angle is negative. And again, I'm focusing a lot on the negative angles because that's where the majority of you struggle. If I'm at negative 9 pi over 5, that is going to be a negative degree angle. And in order to get coterminals, all you have to do is add or subtract 360 or add or subtract 2 pi. They are exactly the same thing. Since I am in radian mode, I am not going to use 360 degrees. I'm going to use 2 pi. So in order to do this, I'm going to add 2 pi to this. 2 pi with a denominator of 5 turns into 10 pi over 5. So what is negative 9 pi plus 10 pi? That is going to be a positive 1 pi over 5, and that is going to be my positive angle. Now let's say I got a negative angle there. You would continue to add the 2 pi, which is the 10 pi over 5, until you got a positive angle. Would I do that to you on the test? Absolutely, so make sure you pay attention to that. Next, how do I find my negative angle? My negative angle is I'm going to this time simply subtract 2 pi, which again, with a denominator of 5, that's going to be negative 9 pi over 5 minus a 10 pi over 5 to give you a negative 19 pi over 5. So watch your negatives, pay attention to what you're doing, do not make silly mistakes, and watch your denominators. That is coterminal angles. Next set of instructions is going to be find the point xy on the unit circle that corresponds to the real number t and evaluate, if possible, the sine, cosine, and tangent of each angle. Now, I really helped you out with this. I'm going to focus on number 21. And I gave you a bunny trail here. I want your brain to think and train itself accordingly. So whenever you see any type of angle, the very first thing I want you to do is to think, what quadrant is this angle in? And the most important thing is looking at that denominator. That denominator in radian measure is a denominator of 3. So therefore, if you're memorizing your quadrant 1 is 60, 45, and 30. Hands of the clock is 1/2, square root of 2 over 2, square root of 3 over 2, yes? That means if I have a denominator of 3, I am talking about a 60-degree angle, and that ordered pair is 1/2 square root of 3 over 2. So I know the ordered pair, but I need to find the quadrant in which I lie. So again, I am going to come right back to my standard position, and I have a negative angle. So I'm coming over here and saying that's negative 3 pi over 3. I'm going clockwise rather than counterclockwise. There are 3 slices in the bottom, and I need 1 more slice from the top. So I'm in quadrant 2. When you are in quadrant 2, you are going to be in the negative positive quadrant. That means the x value, which is also known as the cosine here, is negative, and the y value is positive. Okay, so this makes it very easy for me to lay out exactly what I have to know here. So the sine is the y coordinate, so that's the square root of 3 over 2. The cosine is the x value, that's negative 1/2. Tangent is always going to be your y value over your x value, so those 2's cancel out, and I'm left with negative square root of 3. If I know my sine, then I know its reciprocal function, which is cosecant, and that's going to be 2 over the square root of 3. Guess what? I will elegantly dance my pen across your paper and mark off lots of points, so make sure you rationalize that denominator by multiplying by the square root of 3 over 3. So that gives you 2 square roots of 3 over 3, and that is going to be your cosecant. The reciprocal of cosine is simply negative 2, and then the reciprocal of tangent is going to be negative 1 over the square root of 3. Again, rationalize, or I will take points off for that. And that is how you are going to do the next page of that. Okay? So that page should not be too much trouble for you. You guys should be pretty good at that. Again, this right here, the quadrant and the point, I'm probably not going to ask for that on the test because that's me giving you a bunny trail. And I don't need to give you a bunny trail. It's your job to know what I'm asking whenever I ask for those 6 trig functions and how to obtain them. Next page. The next page this time says evaluate the 6 trigonometric functions using the period as its aid. Whenever I say use the period as its aid, that means that this is a corkscrew angle. A corkscrew angle means that it is over 360 degrees, which means it is going to need to find its coterminal angle. So right here, number 23, if I'm looking at the sine of 5 pi and I want to know its coterminal, you are simply going to take 5 pi and subtract 2 pi. That gives me 3 pi. Am I on the unit circle? No, I am not. Subtract it again, and that gives me pi. So my coterminal angle on the unit circle is simply pi. What quadrant is pi in? Well, that's a silly question considering pi is actually one of the quadrant angles. So you are just going to say that this is a quadrant angle, and you're going to be done with that. It doesn't make up a quadrant, okay? What point is pi on that unit circle? Well, that is going to correspond to the point negative 1, 0. So from there, you're going to say, okay, if the sine of 5 pi is the same thing as the sine at pi, I'm looking for the y value, so that's going to be 0. The cosine is negative 1. The tangent is going to be your y value over your x value, which is still 0. The reciprocal of sine, which is 0, is going to be 1 over 0. Guess what? 0, it doesn't play nicely in the denominator. That's what we call undefined. Secant, the reciprocal of cosine is going to be negative 1 over 1, which is just negative 1. And the reciprocal of tangent is going to be 1 over 0, which again, 0 in the denominator is sad. It is undefined, so therefore it's not possible. Okay, so that's 23 and 24. Those are the same thing. 25 through 27, easy peasy. Plug that right into your calculator. Make sure that you are in the correct mode. This one is a radian, so you need to be in radian mode, degree mode, and radian mode. So pay attention and look for that R or for that degree symbol. That brings us down to the last set of instructions on this page. It says find the exact values of the 6 trigonometric functions given the following triangle. Please simplify and rationalize the denominator. Please read that. Please know it's in all caps. That means if you do it, great. If you don't do it, I'm taking points off. Very first thing you need to understand is that we are a right triangle. And since we are a right triangle, that means I need to go ahead and I need to find the missing side. Since I'm a right triangle, I can use the Pythagorean theorem. So this is going to be 4 squared plus b squared is equal to 6 squared. So this is going to be 16 plus b squared is equal to 36. So b is equal to the square root of 36 minus 16, which we all know to be 20, and 20 is 4 times 5. That 4 pops out as a 2, so b is 2 square roots of 5. Again, from here, you are going to use SOHCAHTOA. This is not anything new. You've used this in geometry and in Algebra 1 again, so make sure that you are understanding that is SOHCAHTOA. So go ahead and label that triangle to remind you, to help you not make mistakes. 4 is opposite, 6 is the hypotenuse, and 2 square roots of 5 are adjacent. So what that means is if I'm doing sine, I want the opposite leg, which is going to be 4, over the hypotenuse, that is going to be 4 6. If you leave it like that, I'm marking it wrong. Please reduce, that is 2/3. If I know sine, I know its reciprocal function, which is secant, so that's going to be 3/2. Cosine. Cosine is going to be your adjacent leg, which is going to be 2 square roots of 5 over your hypotenuse, which is going to be 6. Again, if I know that, then I also know its reciprocal function, which is going to be 6/2 square roots of 5. Notice this is not reduced, so reduce this first, and you're going to get the square root of 5/3. Same concept. Rationalize as you go, making sure you do not mess that up. Yes? And the last one is going to be tangent. That is going to be your opposite leg over your adjacent leg, which is 2 square roots of 5. And that is going to give you 2 square roots of 5/5, which is just simply going to be the reciprocal function of cotangent, which is going to be the square root of 5/2. Pretty simple problem there, simple triangle. The biggest thing is you guys are not simplifying or rationalizing, and I will mark off points. Next page I'm going to talk about is number 31. Use the given function values and the trig identities to find the indicated trigonometric values. Now, we've talked about this multiple times, and whenever we have done this, the biggest thing that I can tell you is that you need to make sure that you know A, what quadrant you're in, B, you need to know your reciprocal functions, and you need to make sure you have your formula sheet around, and I will give you that on the test. I will give you the formulas that I want you to have on the board. Okay, the very first thing you need to know is that my cosecant is given as 7, so therefore the sine is the reciprocal of that, which is 1/7. Secant is given, the reciprocal of that is going to be cosine, which is 12/7 square roots of 3. Again, rationalize, or I take points off. That's 12 square roots of 3 times 7 times 3. The 3 cancels out with a 12 to give you a 4 up top, square roots of 3 all over 7. Tangent. Well, I found my sine and I found my cosine, so that seems pretty simple. I'm just going to have 1/7 divided by 4 square roots of 3/7. And again, use that nice concept of writing it horizontally and do keep, change, flip. And what you're going to see is the 7s cancel out. You do have to rationalize this again because we always do. And you're going to have the square root of 3/12. Now, this right here, I forgot my formula sheet at school, but I do know that this is the same thing as the cosecant of theta. This is the co-function identities that you're going to find right on your formula sheet. Therefore, I already know that that's the cosecant, so that is going to be equal to 7. You can get extra practice on 4-2 and 4-3 for this section right here. So make sure that if you feel like you are uncomfortable with this on this page, go ahead and go back to your homework on section 4-2 and 4-3 to get extra help and extra problems on that. Okay, the last part on this page is to prove the trig identities. Super easy, but something that all of you are not comfortable with. I need you to rely on your Algebra 2 skills as well as your Algebra 1 skills. Okay, so you're going to take those tools from your toolbox and you're going to say, okay, I have 2 fractions. Your goal is to take these 2 fractions and you're going to work on the left-hand side and manipulate it until it is equal to the right-hand side. You may not touch the right-hand side ever. So you have 2 fractions. These 2 fractions are attached by addition, and when you add 2 fractions together, they must have the same denominator. So what is my LCD here between cosine and sine? My LCD is the cosine of theta times the sine of theta. So I have 2 fractions, and they have to both have exactly the same denominator of cosine of theta, sine of theta. Now, what did I multiply cosine by to get cosine sine? I multiplied it by sine. So I dropped down the current numerator, and I tack on what I multiplied both denominator by and the numerator by. Same thing in the denominator of the second fraction. I have a sine there. To turn it into cosine sine, I tacked on a cosine, and now I'm going to drop down the given numerator, which is another cosine of theta. Sine times sine is sine squared of theta, plus cosine times cosine is cosine squared theta, and that is all over the one denominator of cosine times sine. Now your brain should be having alarm sounding off on it right now because that numerator is a trig identity, and that trig identity is sine squared of theta plus the cosine squared is equal to 1. So that means that whole numerator turns into 1. So what I have now is the cosine, 1 over the cosine, and I'm going to separate this times 1 over the sine of theta. 1 over cosine, we know that to be secant, and 1 over sine, we know that to be cosecant. And most importantly, this is the commutative property. We can just simply swap them, and you get your original right-hand side of secant of theta times the cosecant of theta. Okay? Okay, last page, folks. Okay, 35 through 37 are literally exactly the same problems. The difference between 35 and 36 versus 37 is 35 and 36, I give you all of the information. You have to determine using SOHCAHTOA what you are utilizing in that triangle. 37, I'm not drawing the triangle for you. You have to read it and identify the right triangle and then label that right triangle appropriately for the story problem. So let's talk about number 36. If we're looking at this theta right here of 70, what is x according to the angle 70? Is it opposite? Is it hypotenuse, or is it adjacent? What is it directly across from it? So that is going to be the opposite. And what is 15 according to the angle 70? 15 is the right angle. It's opposite it, so it has to be the hypotenuse. So what trig function deals with opposite and hypotenuse? And the answer to that is going to be sine. So the sine of 70 is going to be equal to my opposite leg of x divided by my hypotenuse of 15. And you're simply going to solve for x. This is extremely elementary problem. It's not that difficult. I simply multiply both sides by 15, and I get 15 times the sine of 70 is equal to x. You come over to your calculator, you make sure you're in the right mode, and you type in 15 times the sine of 70, and you hit enter, and it's going to give you 11.61. And I should probably make sure that I'm in the correct mode. And I am not. I'm in radian, so I'm going to go ahead and swap that out. And I'm going to type 15 times the sine of 70, and that gives me 14.10. Okay? So 37 is exactly the same. And this one right here, this one is simply easy. I'm not even going to talk about it. You guys need to pay attention to it. Be ready for the test tomorrow. Make sure all homework is done. I do believe that there are a total of 8 assignments for this section, so your class preparedness grade is going to be a little heavy. More importantly, the test is on Monday, and yes, my expectations are that you will have all of your work done, and yes, my expectation is that you will have learned all of your material. Okay? Great job, guys. See ya.